Hello students, welcome to today's session of chemistry. As you all know, we have started studying fifth lesson of your syllabus, that is electrochemistry. Before starting today's session, we will just revise what we learned in the previous session. In the previous session, we learned a detailed procedure of electrolysis of molten NaCl. And in today's session, we are going to learn about the electrolysis of aqueous NaCl. So, only one word is difference. That is, instead of molten, we are going to take aqueous NaCl. So, difference is of one word only. Now, is there any difference in the process? Yes. The reactions occurring in both the cells are different. As aqueous NaCl contains water also, and water is a polar solvent, hence it will also get dissociated into ions, and when the electricity or the potential is applied, then H2O will also get dissociated and the reactions will somewhat differ in this case, that is in electrolysis of aqueous NaCl. Okay. In the previous session, we learned about the construction of the cell. The construction of the cell will remain same in both the cases. Only difference is the reactions. So, what are the reactions that are taking place in case of molten NaCl? So, as usual, there are two electrodes. One is anode, another is cathode, and as our principle says that at cathode there is reduction, at anode there is oxidation. So, oxidation half reaction in case of molten NaCl, what is it? Because anode is positively charged, the negatively charged Cl ions will migrate towards anode and where they get oxidized. That means the negative charge is removed in the form of electrons. And as two chlorine atoms, they combine together to form chlorine gas and two electrons are removed. Hence, it is oxidation. Now, these two electrons will come towards cathode through external circuit where as cathode is negatively charged, the positive Na ions, that is Na plus ions, will migrate towards negatively charged cathode and where they are reduced by gaining the electrons which come from anode. As two electrons are coming from anode, so two Na plus ions will be involved in the reaction to give two Na atoms. Thus, what is the result of electrolysis of molten NaCl? At anode, we got a pale green chlorine gas, and at cathode, a molten silvery white sodium is formed. So, decomposition of NaCl into metallic sodium and chlorine gas, that is the basic reaction which is a non-spontaneous, which occurs when we apply electricity, and thus we get conversion of electrical energy into chemical energy in case of electrolysis of molten NaCl. So we learned this in the previous session. So let us begin today's session in which we are going to learn about the electrolysis of aqueous NaCl. So the electrolysis of aqueous NaCl can be carried out in the same cell. In the cell used for the electrolysis of molten NaCl using inert electrodes. Inert electrodes, those which don't take part in the reaction. So, we are using carbon electrodes. So, the figure will be same as we have seen in the previous session. So, figure is same. Only difference is in one label that you have to write. Instead of fused NaCl, you have to write aqueous NaCl. The remaining figure, everything will be same. So, I have written here figure 5.4, so I am showing the figure 5.4 here. Only difference, when you write or when a question is like write down the electrolysis of aqueous NaCl, you have to draw the same figure, only one label will be different. That is, instead of fused NaCl, you have to write aqueous NaCl. So we are using same cell to carry, hence the construction also will be same as in the previous session. What is it? It consists of a container in which aqueous NaCl is taken. Two graphite electrodes are immersed in it. They are connected by metallic wires to a source of direct current, that is battery. Understood? Now, the fused NaCl here is replaced by moderately concentrated aqueous solution of NaCl. The solution should be neither it should be dilute nor concentrated. It should be moderately concentrated. The water involved in the electrolysis of aqueous NaCl, it leads to electrode reactions that differ from electrolysis of molten NaCl. So only the difference is in the reactions. What is it? We will see it now. We will see one by one. First is a reduction half reaction at cathode. So do you remember that? At cathode always a reduction, and cathode is negatively charged, anode is positively charged in case of electrolysis. So at cathode what will happen? There will be reduction at cathode. And which ion will go to cathode? So as we have taken NaCl, that means Na plus Cl minus ions will be formed after dissociation. That means as cathode is negatively charged, Na plus ions will migrate towards cathode and they will get reduced to sodium ion atoms, that is neutral sodium. That plus ion charge on the Na will be discharged. That means those Na plus ions will accept one electron to form metallic sodium. But the reaction at cathode, two reactions, and which are both are reduction, those will compete with each other. The first reaction is reduction of Na plus, in case same as in case of molten NaCl, and the reaction is also same. The second reaction, which is a difference, and which is it? The other is reduction of water. As water we have taken, in oxidation also and in reduction also we will see involvement of water. Here also water gets reduced to hydrogen gas and the reaction is like this. That means H2O will accept electron because it is reduction and will get converted into H2 gas plus 2OH minus ions. So water will get converted into hydrogen gas by the removal of 2H minus ions by accepting 2 electrons. That means it is also reduction. It takes place in case of aqueous NaCl only. So this is the reaction, second reaction. Now, out of these two reactions, which one will be the prominent? That we have to decide. For that, a new concept, that is the concept of standard potential, that we have to consider. We are going to learn about standard potential in detail later in the same lesson. Just now consider that the standard potential for the reduction of water is higher than that of reduction of Na+, if we compare these two reactions. Hence, the probability of reduction of water is more in this case. That means water has much greater tendency to get reduced than Na+ ions. Hence, the second reaction, that is twice H2O plus 2 electrons gives H2 gas plus 2H minus ions. The tendency of this reaction, hence reaction 2, reduction of water, is the cathode reaction when aqueous NaCl is electrolyzed. So, actually both reactions are taking place, but the standard potential of reduction of water is more. Hence, this reaction overtakes the first reaction, that is reduction of sodium. So when we observe finally, we say this reaction prominently and not the reduction of sodium. So Cathode reaction in case of aqueous NaCl is only the second reaction, that is reduction of water to hydrogen gas. Now, the second half reaction is oxidation. What happens when oxidation takes place at anode? Now at anode, as usual, it has positive charge. So Cl minus ions will migrate towards anode and they will be oxidized by removal of those electrons at anode. But again, here also oxidation of water is another reaction taking place at anode. So we'll see that at anode there will be competition between oxidation of Cl minus ion to chlorine gas, as in case of molten NaCl, and the oxidation of water to oxygen gas. That is second reaction taking place at anode. So first reaction is same that we have seen in case of molten NaCl. That is twice Cl minus ions will give Cl2 and 2 electrons. Why 2 coefficient is taken here? Just we want 2 electrons to remove. Why? Because 2 chlorine come together to form a chlorine gas. So always we see removal of chlorine. Hence we have to balance it by taking 2 Cl minus ions. Thus, this is the reaction same as molten NaCl. But one more reaction takes place, and which is oxidation of water by removal of electrons to form oxygen along with removal of 4H plus ions. Do you remember in case of reduction 2OH minus ions are removed, and in case of oxidation 4H plus ions are removed. Their hydrogen gas is removed at a cathode, and at anode oxygen gas is removed with the removal of 2 electrons. As this is oxidation, 2 electrons are removed. But again we have these two reactions compete with each other. Again, standard potential plays important role to decide which one will occur prominently at anode. Hence, the standard electrode potential for the oxidation of water is greater than that of Cl minus ion, or water has greater tendency to undergo oxidation. Understood? So here again the reaction number 2 is prominent. Hence, it is therefore expected that anode half reaction would be oxidation of water because its electrode potential is higher. But there is one twist. If we carry out a repeated experiment, same experiment, then those experiments they have shown that, however, that the gas produced at anode is chlorine and not oxygen. Both the gases are produced. But when we observe actual results, when we carry out the experiment, that the gas released at anode is chlorine and not oxygen. That means the tendency of formation of chlorine is more at anode. So this suggests that anode reaction is oxidation of chlorine to Cl2 gas, that is Cl minus ion to chlorine gas, because that is the actual observation. That means what happened actually is overall cell reaction we have to see. Overall cell reaction, I have told you, it is the sum of, or it is the addition of cathode half reaction and anode half reaction. Now, it is sum of electrode reactions. Which is prominent reaction at anode? It is formation of chlorine gas. So it is anode half reaction, which is oxidation at anode. And which is the prominent reaction at cathode? That is reduction or formation of hydrogen gas. So this is the cathode half reaction. Twice H2 plus 2 electrons gives H2 plus twice H1. If we add both of them, then we will get overall cell reaction, and the overall cell reaction will be like this. Twice Cl minus ions. If we add 2 electrons, will be cancelled from both the sides. So 2 Cl minus plus twice H2 gives Cl2 plus H2 plus 2H minus ions. And this is overall cell reaction. So, electrolysis of aqueous NaCl gives what? At anode we get chlorine, at cathode we get hydrogen. So the results of electrolysis of aqueous NaCl are: first, we get hydrogen gas liberated at cathode. Secondly, we get chlorine gas released at anode. And one more thing we get here, because Na plus ion remain unreacted at cathode, and there also OH minus ions are also formed. Both are formed at cathode. Hence, they combine together to form NaOH. Hence, NaCl solution gets converted to NaOH ions or NaOH solution, we can say. So, this is the result of electrolysis of aqueous NaCl. That means hydrogen gas at cathode, chlorine at anode, and the container contains NaOH solution. So, what will be the assignment for this session? Assignment is same what we learned. That is, you have to explain electrolysis of aqueous NaCl. That means again you have to write the construction by drawing the figure, and then oxidation and reduction half reactions, and then overall cell reaction, and finally the result. So this is also the question may be asked in the exam, like explain electrolysis of aqueous NaCl. So write down in detail, open the textbooks. You will not get the figure of electrolysis of aqueous NaCl, but it will be the same as that of fused NaCl. So only the difference is in one label, and that I have told you. So thank you.